All right, checking my audio. 1, 2, 3. Okay, I can hear myself. We have everything wrong in our Emacs, so we're gonna kill that one and fire up new Emacs. Because that was the game development. Game development Monday through Thursday, compilers on Friday. This is like our variety day, our break up the slog day. Do something else interesting and hopefully creative. Today, short stream. I have to go help somebody in 2 hours, and then I'm going camping after that. So can't even do a two-parter here. But I do have some fajitas I'm going to deep Dutch oven, so looking forward to that. Yeah, short stream, couple hours. So hopefully we can get through this bug. Hopefully it's something simple or obvious that we can track down pretty quick. We just barely started taking a look at this last week on Friday. So let's open our project up. Oh, good heavens. Okay. La 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 la. Okay, so we're starting to track down this bug. We could not test this one because this bug. So we got to solve this bug before we can finish that testing. To do, yeah, so this bug, the DFAs don't all come in right, so it may also be related to this one. We'll take a look at both of those while we're at it. So let's get our day lined up here. Day is October 4th. Goodness gracious. So we're going to resume this one. We'll take a look at this one from our to-do list. Started debugging the regex issue. Remove the concept of a group node from the NFA. It simplifies things nicely. The NFA looks okay, just the DFA looks wrong. We'll show all that here in a minute, but basically, did not find the issue before the end of stream. Okay, so that should be a good update for what we were doing last week. Okay. All right. So that's where we're at. Let's see where we were. Our to-do was not saved. We'll just amend the last one. This isn't a functional change, just a documentation change. Did I? There we go. Which brings us to NFA to DFA converter. Now, back in the day, I stole this code out. Here we are. if defined DFA debug. Oh. What we want to find out is what's going on. So let's turn that on. So, -d DFA debug. That should include an awful lot of the logging of what's happening in that NFA to DFA. I may have, oh, it didn't break, so that's good. I think I specified a command. Okay. So what we're looking for is to run source builds debug VV on the project. What's in main? Okay, so we want to do that. We can go ahead and just log both of these as well. Why not? So we can see it in different forms. DFA as a log table. Just get all the outputs, right? Okay. Rebuild this one. Hopefully this debugging doesn't take us too long. Hopefully it's something silly that we did when we ported that code over from the old sandbox code. If that's the case, I don't know what we're doing for the rest of the time, but hopefully I'm afraid it may take us more than 2 hours to solve this bug. It's the complex part of the system. A lot of moving parts. So okay. VV project. Should be it. Here's the output we're perhaps interested in. So first of all, let's look at the rules we set up. So it's test.vv project. We want test.v tokenizer. This is it. So we said we want you to find new line characters, we want you to find white space characters, we want you to find C style line comments and Python style line comments. And then English words with underscore, Russian words with underscore, and Greek words with underscore. I guess this is Cyrillic, not Russian necessarily. I did not know this until I was in college when I had a friend who spoke Mongolian. Mongolian uses the Cyrillic alphabet. That's what we would expect in our parse tables. So if we go look at NFA table, blah, 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 there's the \n \r that we care about. You'll notice that there are 2 other exclusions here. They're for, basically here in state 7, we get the first /. Then we expect the second /. And that goes to state 9, where we get 0 or more newline characters. Anything that's not a newline, exclusion. The same thing here. So this must come off of this one, a hash followed by 0 or more things that are not newline characters. Okay. So like I said, the NFA looks right. This is the table view. We can bring up the other one. Oh, Dravest, good afternoon. Happy Friday. Yes, it is Happy Friday. I'm going camping later. So short stream today, but probably only a couple of hours. So we're looking at the NFA to make sure it looks correct. And it does with respect to the things we care about. So, I know I had a thing. Graph viz. Oh, here we are. NFA. We'll do the DFA while we're at it. Okay. So we can bring up that NFA DFA thing. Just a moment while I do that. BV NFA PNG. Can I share this in a meaningful way? Okay, I can't get this to show up. So, we'll share screen. Make it full screen. So this is our NFA, that file. Or. Here's our new line carriage return. Or a new line followed by a carriage return. And yes, we do need to fix how we print these things out. Right now it's not great. Okay. So you can kind of see what's going on. The NFA looks correct. Which is why it's puzzling when we go to the DFA. It's not full screen. Here's the DFA. White space here, as many white spaces as we can consume. // anything that's not a new line character. Same with the hash, nothing that's not the end of the line. A through Z, A through Ya, alpha through omega, and our syntax. So where did the \n go? This \n here. These didn't show up. And I need to know why that one dropped out. Where did it go? Which is actually state 0. Is that a reason why? There's something weird happening with state 0. So that's what we've got to investigate today. Which is why we enabled all of this output. Loop 0. We start off with one state.
Okay, that needs to stay in the living room. Stop.
Main loop is done. So this is one time through the loop. We begin a new loop. And there are 8 states. Main loop begin, there are 9 states. And this is the one time we don't change anything. Basically, you iterate through until you don't make a change. That's kind of how the main algorithm here works. We start it with our NFA start state, and we say anything we get to from here is in this state. And for each thing in that state, you say, what's the next place I can go? And those are the transitions. When you make a transition, you take the NFA state you use to make that transition, and you start that as the seed to our next closure. That closure when I take everything I can get to. So you just keep iterating through, and when you create a new state, you then have to go through the whole loop again. Finalize DFA state. I think right about here, I would like to know when I finalize it, what does it look like? Here it is. Finalizing this DFA state. Create a temporary NFA closure. Use the full closure. We ask if it already exists or not. As long as any state was created, we have to iterate through again. Can we accept new DFA transition was created? Rule thing, token thing. Every rule only specifies one, so this is more like a clarity thing. Okay. Transition, token ID. Add DFA transition. Finalize DFA state. DFA state. State ID. Just add a few little details here and there as we go. So what are your big plans for the weekend, Drevest? Still unpacking boxes, I assume? Or packing up boxes, I guess. Hmm. Um, maybe we want more. The transition contains an op and a occlusion set. That is something we also log. Okay. ToString. Let's see here. The operations are part of NFA state. NFA state op name. Op string temp C string. And we need to delete the temp C string. We do take ownership of that. Okay, so we get a lot more information about what state we're looking at now. In theory. Okay. Oh, come on. Transition does indeed have an op. Oh. Oh. Operation is NFA. Okay. That's all the temporary stuff going in between. Next. Rule. Operation. Yeah, hopefully we find the issue quickly here. Exclusion. Exclusion. Huh. Expect it to pop up on that first go loop. Okay. Right here. All right, we've got a DFA state. Finding the closure. White space / sharp. English, Cyrillic, Greek. Symbols. Then it claims it's done. So it never got from the NFA the last thing. Huh. Yeah, well, that definitely points me in a direction. So when we hand in a closure, we say, here are all the states we know have to go in. Find all the states in the NFA that we can get to from here without making any changes. Compute closure. This is basically our destination, our target. Clear them out just in case. For each state in NFA states, clear visited, closure states insert. Okay. So whatever we send in is part of the result. That's all that does. Boolean wasn't an item added. If we add an item, we then have to take it into account in the closure. If the state was not visited, right, so this prevents us from looping forever. And the state is marked as visited. If it's an alternation, we insert 1 or 2. If we inserted one, we were told about it. As long as we keep adding items, we'll keep going. So we look at our NFA table. Somehow never finds this one. This isn't right. The start state is this one. It goes to 27 or 28, which can go to 23 or 24. 5, 19, 20, 21, 22, 15, 16, 11, 12, 17, 11, 12, 11 can go to 6 or 7. This table is kind of upside down of what we might naturally think of. So 6 or 7 can go 8, 9, 10. Which can go to 9, that's fine. 0 or 4. So if we go to 4, white space can keep going around and around. Or 0. So this is here. This should be 0 can go to 1 or 2. 1, 2, 3. What if we change it? Let's go to part of this may be because of this. What we really want is the NFA pattern for, that one's fine actually. If we just do the expansion a little bit differently, what if we go with \n or /r \n question mark? Is that, I mean, this should work. So let's see, we're saying basically state. State A, conclusion, add character, so basically when we get a new line character, not, let's not do this here. Let's do it here, I think. Okay, so state A. State B. State C. Okay, so there's this, this, and this. alternation. Pushed on. Now we begin the second group. In a new group. At the R. Carriage return. At the end, newline. Okay, so what we're doing is we're getting the \n or a \r followed by a \n, except what would be an optional, a 0 or 1 in here. Another fragment group. The main problem here is that I don't think this is the problem. Question is, the NFA looks right. Need. So in the output closure, you'd output the NFA state numbers that are in the closure, right? In the NFA state point to state ID. Okay. Oh. Oh, okay, hold on. Actually makes it a tiny bit more complicated. Bool added equals this if it was actively added. If it was added to. Okay, let's pick that for a test drive just to see what we get. Oh, I thought we had. Okay. For whatever reason, that first closure is not getting process there. Oh, okay. Segfault. Scan pattern. Okay. Let's put restore source pattern. This one I don't think needs our attention. So the first one is what we care about, I think. Closure. Given NFA state number 5, add state what? Oh. To state ID. Okay. Given NFA state 29, add. Now I think the one we care about, if we go to the NFA, is 0, which needs to pick up 1 and 2 and 3. 0, 1, 2, 3. So given 0, somewhere NFA state 1 is never added. Oh, interesting. So somehow this closure adds NFA state 0. And all of these zero, 6, 11, 15, 0, 6, 7, 11, 7, 4, 12, 11. So it adds state 0. But somehow state 0 never adds state 1 or state 2 here. Oh, curious. Because these states, let's see here, let me just pull up this thing next to it. Do a side by side. See here. Let me see if I can lay this out so that it's as visible as possible given the constraints. Okay, so if you look at these states that it's adding 27, 28, so that's 27 and 28. Our start state is 29. Adds 27, 28. Then it adds 23 and 24, so the two outputs of this alternation. Then it adds 19 and 20, which are the two off of this alternation. Then it should add 15, 16, 11, 12, 6, 7, 0, 4. But this 0 should add 1 and 2. After 0, 4, I should see 1 and 2 get added here. And the question is, why isn't it? That's good information. This is what I mean by closure. This is an alternation, so I can go left or right, and this doesn't actually check anything. It means you have to try both. So a closure says, where can I get to? And it gets everything until it has a concrete thing. It goes down every path until it hits concrete. State 0 never adds more. I want a something. No. Was this visited? That's a bad sign. Otherwise, I don't really care. If it adds a state which has already been visited, that could indicate where the issue lies. If that's not the case, this is probably a push. Okay, so we're gonna try that. We're gonna log more information. Which means this output blows up even more. Okay, so from 28, we add 27 and 28, which is visited. No. Okay, so that's why it's not being added. If we go to state 0, add NFA state 0, it's already considered visited somewhere else. Okay, so that's our problem. If it was added, you only have to clear the visited on it. It has to be considered once, and it can't have been considered if it wasn't added before in this loop. Which means now, here it is. That's where we wanted it. \n\r goes to state 1. If we get an R, oh. Okay, so we still have the issue that we're forming this piece wrong. If we get an R, it could be followed by an N. Okay, so we're still forming that wrong, which is fine. But now that means we should also be able to test. Actually, let's go back to here. These log statements. If defined DFA debug. Okay. So that should solve that issue. If we go to our test.btoke, we should be able to put string back in here. String will be kept. It's a quote, ending with a quote. Anything which is not a quote or a backslash followed by any character. Anything which is not a quote or a backslash or a backslash followed by a character. So we can't like end the string on it. Backslash. Okay. Okay. I wonder. Didn't really have access to it there. Oh, so that may very well fix the newline characters. So just unhappy. And what I don't want, this is one of those weird compiler bugs. STL iterator. Blah blah blah. Compute DFA states. ToString of a null, which is a converter of 396. Compute DFA states, fine. And these are control. 396, this line right here. Transition, inclusion, I mean, we can transition, inclusion, ToString, fusion. We have a inclusion set iterating over all of its stuff. Okay. ToString, okay. I wish the crash would happen in here where I can actually see it. It says it's in the STL list. Which is a list of rules. So each time we go through the rules, have the inclusion set have a null rule. Huh. If rule equals null, firstly, what the why this folly? And then second, string length, I don't think we add the empty. if rule is equal to null, type string equals 5. Stir copy into temp string. I just want to see where this null thing is popping in. Mostly. Oh, for Pete's sake. Oh, for Pete's sake, fine. We'll make it fine. We'll make a equals new char 5. Texture equals other. Okay. Oh, it's still crashing. Backtrace. $396 still. Not this one. This one is in NFA 2 DFA converter 396. Yeah, if we run it without that in there, put it in there, it breaks things. I'm checking for null in the places where it can do that. So why is it? I don't reference rule unless I've checked. Now, it shouldn't be null in the first place. How would it get null? I don't know. Run it. Backtrace. ToString. The occlusion set itself is null. 396. That should also be impossible. Somehow this inclusion set is null. Yeah. What? Oh gosh, 130. We're so close. Huh. Okay, I don't think I have time to deal with that. Probably have to leave this bug alone for now. Stack dump with null transition inclusion. Okay, so let's mark what we've got so far. The closure wasn't marking newly added states as unvisited. So some states were then being checked for the next time through the closure loop. That should fix that. Backslash ends pattern from pattern to NFA converter. Is still wrong. That's a different matter. Okay. Go to NFA to DFA converter. Okay, we're gonna go to test.vcode. We're gonna take this one out. We're not testing that right now. Do a full clean and debug. So the next thing we have to do is create the \n\r structure correctly. So do this. It all works. We have \n\r, which is wrong. It should be \n, and then down here it should be \r, which leads to another state which checks for an additional \n. Yes. So these three states are wrong. actually, this inclusion, I think that's all we have to do is change that inclusion. All right, if we go to pattern to NFA converter, we search for N. We don't want to be in an inclusion when we check for that one. Here. So we need either N or. I think that's it. I think that's all the fixing we need to do there. What's it called? Oh, just give it the character. Oh, there we go. Oops. I believe that will. We can also remove that debug flag. There we go. This should see us able to test that other thing in the last half hour we've got. In theory. Boom. So it's either a \n, or if we get a \r, we go to 2, then we look for n, which goes back to 1, which must accept. Yeah. So on a \n, it's forced to accept. There. Oh, wait. Nope. Nope. Go \n. Or we accept. So this state needs to accept. That's where the 0 or 1 needs to come in. So we throw in a character, or \r. Then we need a 0 or 1 here. We can do this. Character should be a 0 or 1. This one should be optional. Because the next character we get is anything else, it should accept anyways, just on the \r. Because Linux uses just \n, Mac uses just \r, Windows uses character return and a line feed. Question mark. So I make a 0 or 1. That comes on \n after \r should be is optional. I think is this. Oh, so we are redeclaring things, huh? Okay. Else. And it just dumps out. Of course it does. The R, here's the end. Put the \n on. Not my favorite thing to debug after months of not looking at it. It gets weird. Okay, so we go \n, we go \r. R goes to 2. 2 can accept. Or it can get an N, which goes to a forced accept state. There we go. Now, in theory, we can look at this one again and the NFA one. Back over to show what we're looking at here. Or newline or carriage return optional newline. And the DFA then looks like this. We get a carriage return. Or get a line feed or a carriage return followed by line feed. Or any syntax that's a single character that we acknowledge. Those all go to forced accept states. Perfect. So that looks pretty good. So that's our DFA. Which means we should be able to test now. the other thing, which I forgot what we were even doing. Okay. So maybe we can comment out that. Ooh, okay. Let's go to the journal. Oops. The pattern to NFA converter. Now builds the, let's see, I have to go back to pattern. Pattern like this. Instead of what it was before, which was one of \n/r or r followed by n. Should work better. We should now be able to test the task from last week. Okay, journal to do, occlusion set, code snippets, NFA to DFA converter, pattern to NFA converter, and okay, now it makes sense. Okay. Make sure I'm not doing something I don't intend to. Mixing up NFA to DFA closures and /n handling. Should be ready to test inline processing. Okay, now inline processing. We've got 15 minutes, then I gotta go. So let's go to Tokenizer. So VV test parser. Cool 1,500 lines of code. I don't remember which flags we had set. We're doing fopen iterator based text traversal, helper functions. We're doing a batch process, dispatching on a switch, and we're using lambdas. We go with bind. Okay. So we're gonna run clean and debug. Oops. Clean and test. I don't remember what's in the test anymore. So we added a bunch of new lines to this one. Hopefully it just magically works. Okay. Source builds debug VB test parser. Okay, so here's our defines. Our text has some new lines in it. So token 1 is hello on line 1 starting at character 0. I agree. Then we got a new line, character, or the omega symbol shows up one character. The first character, we're gonna probably have to offset these by ones. That's line 2. So we get a comma at line 2, character 2, world line 3, character 1, and the exclamation mark line 3, character 6. 1, 2, 3, 4, 5, 6. I agree. Text has 3 lines. I almost agree. Okay. So let's go to assets. Oops. B assets. Code snippets. Token. Log. Running 1 to the line number, we should add 1 to the character in line. So instead of having an index, we're having an ordinal number. That'll fix one thing. So I think most people are like the 0th character. Usually line numbers and character numbers are not indices. Okay. So that's part 1 of our testing. And then test. Literally just doing the 1 line. Index equals 0. Index less than line count. Index. Last thing we would like to do, if we can. Yep. Text has 3 lines. Hello, Omega, and world. Oh, interesting. The white space is not counted towards the start of line. So the end of line munches up those backslashes. So when we register a line, we do in text buffer. Oh, code snippet. TxtBuf. We mark the define line. Okay. Here's the deal. Got 10 minutes. This end character will always be a carriage return or a line feed, and we need to back that off. I don't want that in the line at all. Is character ref already a friend? It is a friend. Great. Therefore, lim underscore value is equal to either \n or n underscore value is equal to \r. I don't care what the construction is. Oh, kind of do. Hold on a second. Okay, so end dot. What's the advance? It's the opposite of advance. Opposite of advance. Probably retreat, but I'm not sure that's the word I'm looking for here. Retreat to oh, this gets ugly for the UTF-8 case. The other two are not too bad. Got 7 minutes to do this in. Okay, so our byte count minus equals same underscore. Oh, that's not right. Byte offset minus equals underscore byte count minus equals 1. Oof. Back to okay. Going backwards through a UTF-8 buffer is a little bit more expensive, but in this case, it's not that high of a performance hit because it's only on the new lines. So byte count has to be recomputed. Okay, these are the two that we need to manipulate and then update. Okay, so our byte offset. Bytes retreated. So we're going to move backward a byte. We're going to get the byte at that offset. So unit 8 P equals that. Then we're going to check for the continuation byte, which is this. If our byte masked the upper 2 byte bits equals 1, 0. If B and C equals 8, break. Okay, that's our new offset. Our char offset was updated. Update does that. I think that's it. Update. Assert that the number of bytes we retreated is equal to our byte count. So if we had to retreat 3 bytes, it had darn well better be 3 byte character that we retreated through. So the byte backed up 1. Okay. Char ref. In this case, it's much, much simpler. Byte offset and update. This is the same for char ref ASCII. Actually, there is no byte offset. That's it. Which then brings us to TxtBuf. Back 1. Then we form a line. Let's try that out. The test version, there we go. Record. No. New line. char inline. Bunch. We begin. Start new token. New line. Bunch. That's right. Let's see if walking backwards through a UTF-8 buffer is trivial as we think. Oh. Back one. TxtBuf implementation. Contents. That's what we're looking for. Oh dear, just about done here. Gotta get going. Let's just make this work, please. Oh. Really? And is marked as const? Okay, fine. Let's see here. Char F. Whenever we would back one is in the Tokenizer. Oh no. TxtBuf. Character reference C equals end. We'll get it figured out here. Then I gotta go. Hopefully this test works. Those lines pop up with no new line characters at the end in the console. It didn't. Perfect. Shoot. If the lines are being numbered correctly. Okay. All right. New lines are being tracked nicely in the tokens now. However, the TxtBuf lines contain their new line characters. Took a stab at removing them, but it didn't take. We'll look at next week. Testing and minor updates for TxtBuf line numbering lines. Okay, we're gonna call it good there. Thanks for joining. Sorry for a short stream. I gotta get going. Gotta go help some lady and then off to camping. So I will see you all next week. Bye bye.